Assalamu alaikum. Good evening, everyone. So this session is related to discussion of topic 2.1, 2.2, and 2.3, the class test. Starting with the MCQs, the first question: a gas syringe which is containing a fixed mass of air, the volume of the air is 240 cm cube, and it exerts a pressure of 5 exponent 4 Pascal. The air is slowly compressed, and the temperature does not change until the pressure changes to 1.5 exponent 5 Pascal. What is the final volume? So they have to use the Boyle's law. According to Boyle's law, we have the formula P1 V1 equals P2 V2. So P1 is the first pressure. That's the first pressure P1. The first volume is V1. The second pressure is P2. And the second volume we don't know. So when we substitute the values, we'll get as 80 cm cube. And it is obvious that pressure is increased, like 5 exponent 4 changes to 1.5 exponent 5. So if the pressure increases, the volume should decrease. So it cannot be C or D, because in C and D the volume is increasing. So either it can be A or B. When you substitute the values for the pressure and the volume, you will find that the final volume is 80 cm cube, which is B. In question 2, so there is an extremely large increase in pressure is needed to compress a liquid, and gas can be compressed by a much smaller increase in pressure, which Satan explained. Like, because what happened when these molecules come closer to each other, the molecules tend to repel each other. So in liquids, the particles are relatively closer as compared to that in a gas. So when we check the statements, the molecules repel each other very strongly when they are closer. That's true, because when the molecules are closer, they repel each other as they are repelling each other. So it will be difficult to bring them closer or together. That's why A is the right answer. Why not B, C, or D? The attractive force between the molecules are smaller at a large distance. Look, this statement is true. The attractive force between the molecules are smaller, but that does not explain why the liquids are difficult to compress. This statement is true, but it does not explain the idea about compression. The molecule in a gas collide with the wall of a container and rebound. That also true, but this does not this explain the idea of a pressure, but not about the compression. And the molecule and liquid are constantly moving randomly. That's also a true statement, but it does not explain why liquids are difficult to compress. In question 3, a dish of a liquid is left in the lab and some of the liquid evaporate. What happened and why? The liquid cooled because the liquid molecules have more potential energy than gas. That is wrong. Gas is having high potential because the molecule rises. The liquid cooled faster. The liquid cools because the fast moving molecules escape. That's true. The most energetic molecules will escape the liquid surface. The liquid does not warms up. That is totally wrong, because whenever evaporation occurs, evaporation is a cooling process, and in this process, the molecules which are left behind will have low energy. A solid wax is melted in a boiling tube and then it is allowed to cool. The graph shows a cooling curve. What happened between point X and point Y? So we have to first the label. Whenever the temperature is not changing, it means the state is changing. So here, because when we melt the liquid wax, the solid wax is melted, turned to liquid, and then the liquid will cool down. So here we'll have liquid. Here liquid is turning into solid, and here we'll have solid. And why at this point the temperature is constant? Because it reaches a thermal equilibrium. Like thermal equilibrium means it reaches a room temperature when it cool down. Because if something is hot, it will lose its energy to the surrounding until it will come in thermal equilibrium with the surrounding. And in the question they mention a solid wax is melted. So if the wax is melted, like in the beginning we were having a solid, then we melt the solid and convert into liquid. And now we cool down the liquid. So if the liquid will cool down, the liquid will turn into solid. So here we'll have liquid, it's cooling down, then the liquid turned into solid, and here solid, here also solid. But what is happening? Why at this point the temperature is constant? Means it reaches a thermal equilibrium, or the temperature of the room is same as the temperature of the wax. That's why it is not changing its temperature. So what happened between point X and Y? As you can see, the liquid, as the temperature is constant, so its liquid is turning into solid. So B is the right answer. In question 5, what is meant by specific heat capacity of a solid? Or heat capacity, not specific heat capacity. The heat capacity is energy required to change the temperature. So maximum thermal energy stored per unit mass, no. Maximum energy stored per unit volume, no. The thermal energy required a unit change rise in temperature, that's true. It's the amount of energy required to change the temperature of a given mass by 1 degree centigrade. And thermal energy required to raise a temperature to its melting point, that is not the heat capacity. Heat capacity is how much energy we need to change the temperature by 1 degree. In question 6, the distance between the ice point and the steam point is 20 centimeter. The top of the liquid thread is 12 centimeter above the ice point. So ice point means 0 degree and steam point means 100. So distance between 0 and 100, that is 20 according to the question. In the question they are saying above the ice point it is 12 centimeter. So what is the temperature? So we'll use a ratio here, like 100 degrees represented by 20 centimeter, 100 degree change in temperature or difference. So if it is 12 centimeter, it is represented by x. So we cross multiply. So 100 multiplied by 12 divided by 20. So when we simplify this 5 multiplied by 12, so it will be 60. So B will be the right answer. A thermocouple is a type of a thermometer. Which statement applies to a thermocouple? So thermocouple, because it is made up of the metal, and metals, they can transfer the heat energy quickly, so it will respond quickly. So it can measure a rapid change in temperature. So A is the right answer. It must be made up of 3 different metal. That is wrong. It is 2 different metal. Its resistance decreases when one junction is heated. It's a conductor, and for conductor, when we increase the temperature, resistance increases. And distance between the two junction increases as the temperature increases. That's wrong. It does not change. In question 8, a heater is designed to radiate the thermal energy. Which change to design decreases the thermal energy emitted out? Like we want to reduce the energy emitted out from the heater. Dull and dark surfaces are good absorber. If the surface is dull or it is dark, it will be a good absorber. and emitter. So it will absorb energy and it will emit out energy also. So we don't want to make it dull or dark. High surface temperature, if we increase the surface temperature, the energy, because high temperature, hot objects, they lose energy much faster as compared to cold objects. Using a large surface area, so more particles are exposed to the surrounding, so it means it will lose energy faster. If we make it shinier, because shiny and smooth surfaces are good reflectors, so most of the energy will be reflected and small amount of energy will be lost. So D is the right answer. Because which change in the design decrease the thermal energy emitted by radiation. So shiny surfaces does not absorb too much energy, so they will reflect most of it. As a result, the thermal energy which is emitted out will decrease. In question 9, which statement explain how a pressure exerted by a gas on a container? So how we explain the pressure? Gas molecule collide with each other with other gas molecule in a container, but that does not explain that explain how the particles are moving, but does not explain the pressure exerted by the particles on the container. So gas molecules collide with the wall of a container. As a result, when these gas molecules collide with the wall, it exerted pressure. Gas molecule exert strong attractive force on each other or repulsive force. Even repulsive force will be stronger if the particles are closer to each other. But not always it is same. So the force between the particles is very weak, not as strong. Here it is written strong attractive and strong repulsive. But in gas, the particles are not attracting or repelling too much, like it's a weak force. In question 10, when a liquid evaporates, the molecules escape from its surface. Which molecules escape and what happened to the kinetic energy of remaining molecule? So the molecule which escape, the most energetic molecule will escape, and what happened to the kinetic energy of the molecule which are left? That will decrease because the most energetic molecules which are there at the surface gain energy from the neighbors, from the surrounding, and they go out. So molecules which are left behind, they will have low energy. That's why we could say evaporation is a cooling process. So what are the names given to the changes P, Q, R and S? So P is condensation, liquid is turning into solid, so it's freezing or solidification you can also say. Solid is turning into liquid, so that is melting, and liquid is turning into gas, so that is boiling. So it matches with option B. A boiling liquid absorbs thermal energy at a rate of 450 watts. The specific latent heat of vaporization is 2.7 into 10 power 6. How much liquid is vaporized in 9 minutes? So first what we will do, we will find, because the latent heat is energy divided by mass. So we have the latent heat, we want to find the mass, so first we should know energy. And how to know the energy? Energy is power multiplied by time. The power is given 450 watts and the time is 9 minutes, but it should be in seconds, so we multiply it by 60, so it will convert into second. So 450 multiplied by 9 multiplied by 60, that will give us 243,000 joules. So energy is 243,000 divided by mass, and the latent heat is 2.7 into 10 to the power 6. So 243,000 divided by 2.7 exponent 6, that is equals to 0.09 kilogram. Why kilogram? We are getting the answer in kg because the latent heat was joule per kilogram. If latent heat is joule per kilogram, we'll get the answer in kilogram. If latent heat is joule per gram, we'll get the answer in gram. So this is kilogram, but all the options, the answer is given in grams. So we'll multiply by 1000, so it will come out as 90 grams. So C will be the right answer. In question 13, what make a clinical thermometer suitable for measuring a small change in body temperature? Like a clinical thermometer can measure a small change in temperature, so it means it is sensitive. Like very small difference in the temperature can be recorded. So it means the thermometer is sensitive. And how a thermometer we can make sensitive? The amount of liquid in the bulb is small. That is wrong. We should use a large amount to make it sensitive. The bore of the capillary is narrow. That's true. If we use a narrow capillary, we can measure a small change in temperature. Capillary of the capillary tube is longer. That will affect the range. And the glass bulb has a thin wall that will affect the responsiveness, or it will make it quick acting. Like it will respond quickly. So B is the right answer. Because a clinical thermometer can record a small change in temperature, a human body. So as a result, we want to make it sensitive. And how to make them sensitive is by increasing by decreasing the size of the capillary, thinner capillary, make it more sensitive. Then which statement about the transfer of thermal energy is correct? Transfer by radiation does not require a medium. That's true, because radiation can pass through vacuum. So even if it's a gas, radiation can pass, but thermal energy can easily transfer without a medium in the form of wave. Transfer is, so A is the right answer. Transfer is from a region of low. That's wrong. It's from high temperature to low. Transfer upward in fluid mainly through vibration, not vibration, that is by movement of the particles. Transfer in solid by mean of change in density, that's wrong. Density changes in fluid, like liquid and gases, there is a change in density, and that causes a heat energy to transfer as a particle move from one region to another. In question 15, a piston is pulled out a distance of 30 centimeter so that the length of a gas in the column is now 50. The temperature does not change. Look, the formula P1V1 equals P2V2. Because the area is constant, as you can see, area is not changing. So we can also use the formula P1L1 equal P2L2. Because the volume is changing due to the length. So as a result, if we know the length, we can also use P1L1 equal P2L2. So P1 is the first pressure, that is in the question initial pressure is given P. L1 is the first length, it was 20. P2 we don't know, and L2 is 50, the new length. So we simplify P multiplied by 20 divided by 50, that's P2. So when we simplify, it will be 2 by 5 or 0.4. So 0.4 is P2. The new pressure is 0.4 times the first pressure. That's why A is the right answer. The diagram represents 4 thermometers. Which thermometer has a greater sensitivity and which is having the greatest range. Greater sensitivity refers to like greater difference between the marking of a thermometer, like the two marks, 1 degree mark, if there's a greater difference, it means that is more sensitive. And range means the minimum and the maximum value, the difference between the minimum and maximum value which thermometer can record. This is refers to range. So when we check, like different thermometers are there, P, Q, R, and S. So 1 degree mark, if I try to sort out 1 degree difference between 1 degree, so this is 1 degree mark, 31, 30 to 31, this is 1 degree, 0 to 50, this is 50, so 1 degree will be very small because that is still 50, and 100 to 140, that's very small will be there. So which is the most sensitive? So sensitive is Q, and which is having a higher range. Range refers to the values which a thermometer can record. So this thermometer from 0 to 25, so its range is only 25 numbers it can record. This is from 30 to 40, so it's only 10 degrees, 10 numbers or divisions it can record. For the third one, 0 to 250, so it can record 250. And the last one, 100 to 300, so it can record 200. So which is having the highest range? R is having the highest range. So Q is the most sensitive and R is having the highest range. So this matches with option C. Which type of thermometer is used to measure the temperature above 1000, and which type of is used to measure temperature change rapidly? So both cases we use thermocouple, because thermocouple, if we use liquid in a glass thermometer above 1000, it means most of the liquid boils at around this temperature, so it won't be accurate. Liquid in a glass thermometer cannot be used. So, and measure a rapid changing temperature, fast changing temperature. So again, we use a thermocouple because the thermocouples are more accurate. An electric shower takes in cold water at 17 and gives 6000 joules every second. The specific heat capacity of a water is 4200 joule per kilogram degree centigrade. What is the mass of a hot water? What is the mass of hot water supplied by shower in 1 second? So we basically need the mass. We have the formula E is equals to Cm delta T. So E is the energy which we supply, 6000, specific heat 4200, mass we don't know, and temperature change is 37 minus 17, which is 20. So this all is multiplied, other side will be divided, 6000 divided by 4200 into 20. This will give us how much mass supplied. So it will come out as 0.071 kilogram. Then what is latent heat of vaporization? Latent heat of vaporization means amount of energy needed to change the liquid into gas or gas into liquid. The energy required to make the energy required to make molecule expand. Remember, molecule never expand. The size of the molecule never changes. The energy required to make the molecule expand, that's also wrong. The energy required to make the molecule move apart, because latent heat of fusion or vaporization is energy needed to change the state. And when we change the state, we change the distance between the particles. And energy required to move the molecule faster, that is wrong, because it will change the temperature. Temperature does not change when the molecules are moving away. In question 20, air is trapped in a cylinder by piston. The pressure is P and the length is 20. The piston is moved outward and the new move and has a column increases to 40. So the temperature of air remains same. What is the new pressure? So how to know? Look, the formula again in terms of length, P1 L1 equal P2 L2. We take the total length. So P1 is the first pressure P, the L1 is the first length, which is 20. P2 we don't know. And what about the new length? The change in the length is 40, so the new length is 60, because originally it was 20 and changed by 40, so new length is 60. So this is 60. When we simplify, P will multiply by 20 divided by 60. So when we further simplify, it will be P by 3. So B will be the right answer. So this was about the MCQs related to the test. Another video I will share the structure question solution with you.